In this part of the video, let's look at the client of this class hierarchy, and we will focus on dynamic bounding or polymorphism here. So the first one, let's take a look. We're trying to do test shape and create two shape object. We know this won't compile because shape class is an abstract class. You see get area equal to 0. That makes it an abstract function, and the shape class is an abstract class. And for abstract class, we cannot create object out of the abstract class. So that's a problem. So this code won't compile because of the abstractness of that class. Now let's take a look at the test circle. So we use the two constructor to create the circle object and try to access the inherited function get x and try to print out. And take a look at this print. This print is static bounding. So because C1's data type is circle, so print function in circle will get invoked. And now let's take a look at test polymorphism. How do we use polymorphism in C++? So first, let's go ahead and create a circle object. And then if we are trying to do this, this won't even compile. If we're trying to copy the Java code, trying to assign circle object to a shape object, this won't even compile. So remember the big difference between C++ object and Java object is Java objects are all pointers to the real object. But C++ object, look at C2, it's not a pointer to the real object. So in order for dynamic bounding to kick in, we have to explicitly use pointer here. So take a look here. If I have a pointer to shape, you see I declare the type as pointer to shape, and I can give it the address of C2. You see C2 is a circle object. I can take the address of C2 and assign it to a pointer to shape. So this is exactly like what we did in Java, because in Java everything is a pointer. So we don't have to put like the star there. We don't have to take the address. So in order for dynamic bounding to work, you have to declare a pointer to the parent class and give it the address of address of an object of subclass. So then when you do S4 print, this is dynamic bounding because the print function, you see, S4 is a pointer to shape, but the print function for circle get invoked because at runtime it will, because print function is declared as virtual. At runtime it will, you see, let's take a look at the shape.h. This print function is declared as virtual, which means at runtime it will try to determine which print function should I invoke. Is it really a circle or a rectangle? I will invoke the appropriate print function for you. So in order for dynamic bounding to work, you have to declare a pointer to the parent class and give it the pointer to a subclass. And then this time dynamic bounding is working, and this time we give it a rectangle. The get area of rectangle should get invoked. So that's about using dynamic bounding or polymorphism in C++. You have to use pointer to enable the dynamic bounding. And for dynamic bounding to work, the parent class has to declare the function you want to enable dynamic bounding as virtual. That's how the environment know, okay, I might look at other classes for the print function or get area function. So that's the two key things. So as a parent class, you need to declare virtual if you want to enable dynamic bounding for your parent class. And as a client code, you need to use pointer to the parent class instead of like this. Alright, so now let's take a look at another example about dynamic bonding. So if we are trying to keep track of a collection of shape, so an array of shape. So we do an array of pointer to shape because we want to enable dynamic bonding. So we create a circle, then it will give you back the address of a circle. We put it as the first element, which is a pointer to a shape, and similarly, so this is a shapes array, and which contain pointers to a shape object. And we try to find out the size of the array by doing this: size of the array divided by size of individual elements of the array. And we find out the size. Then for individual element, we iterate through this array. For individual element, remember the pointer to shape, I invoke the print function, and you can imagine dynamic bonding kick in because it's a pointer to shape. So it depends on what kind of shape it is. So for the first iteration, the print function for circle get invoked. For the second one for circle, the third one for rectangle, the fourth one for rectangle. And similarly get area. That's another dynamic bonding. And before we go away, we need to deallocate the various shape object we did. Alright, so how about typecasting? So like subtyping in Java. So how do we do that one? So you see, when I have a pointer to shape, I can create a new circle and give the address to the pointer to shape. And then the type of S is pointer to shape. If I really need it to be pointer to circle, then I need to do a casting, and I can use a specific kind of casting called dynamic casting. Dynamic cast will cast a pointer to the parent class to a pointer to a subclass. Similarly, I can typecasting. I'm trying to typecasting it to rectangle. You know this one should crash at runtime, but it compiles fine because rectangle is a subclass of shape class. So I can do that dynamic cast, but it will crash at runtime because this S is really a pointer to a circle. It's not a pointer to a rectangle. And you see, when I do this, that's fine. Get radius. And when I do this, that's fine. You see, the reason we want to cast it to circle is we want to invoke some method specific about the circle. So because get radius isn't defined in shape class, so I cannot say S big arrow get radius. It won't compile because get radius isn't defined in shape class. That's something specific to circle. In order to invoke this function, I have to do the typecasting. And you see this one, it should crash because R really isn't a rectangle, it's a circle. And we can do reference object. We can do reference object like this. So if we declare an object as reference, you see it's kind of like pointer. Actually, essentially it is pointer, but it's just a different syntax introduced in C++. But pointer was in the C word. But sometimes people like to do it this as well. It's a reference object. Actually, it is a pointer. So we can dereference S and put it here, and we can do some dynamic cast to cast this shape object to circle object, then invoke the circle specific function. And we can do try catch. When we do the typecasting, if we do a try catch, here we should catch an error because it's not a rectangle and we are trying to cast it as a rectangle. Another thing I want to point out is about the virtual D structure. And remember here, we purposely put a virtual here. We put virtual here is to ensure the child class destructor get invoked. So we are trying to do our child class a service. How about let's take a look at this sample code. So look at this function. It's fairly simple. I purposely keep it simple just to show the point. We first create an object of circle this way. Then we create an object of rectangle this way. So new rectangle and put it in S. Then I'm trying to delete S. So if I run this function only, like in the main function right now, I have a bunch of testing here. If I comment out all the other testing so that we can see it clearly, only the test virtual destructor here. So let's first read the code to imagine what should happen. So when this one get created, it should first initialize its parent. So shapes constructor should get invoked. We should see that message, shapes constructor get invoked, and then circles constructor get invoked, because you always initialize your parent first. That's what we did. Okay, so we should see two messages about shapes constructor get invoked and the circles constructor get invoked. And similarly, when we create a rectangle, we should see shapes constructor get invoked and the rectangles constructor get invoked. And now let's see. Lifetime of this rectangle is over, so we are expecting to see rectangles destructor get invoked, then shapes destructor get invoked. Because when you destroy yourself first, then your parent. It's an opposite order as a constructor. So we expect to see rectangle destructor get invoked, followed by shape destructor get invoked. And before we go away, C's lifetime is over, so the destructor for circle should get invoked and the destructor for shape should get invoked. So that's our expectation, and let's go ahead and do that and run it to see if it meets our expectation. So let's see, let's compare the code with the output here. So this is our code. The constructor for shape get invoked because you're creating a circle. So parent class constructor get invoked, circles constructor get invoked, which is just right. Then we create a new rectangle. So shapes constructor get invoked, rectangles constructor get invoked, which is perfect. And then when we delete S, the destructor for rectangle get invoked, and the destructor for shape get invoked. It works well. And then C's lifetime is over. The destructor for circle get invoked, destructor for shape get invoked. So everything works perfect. And now, what if I change something? What if I get rid of this virtue here? If I get rid of this virtue, the same code, let's run this same code again. The only change is I get rid of the virtue. Let's take a look at this one. So the constructor, nothing get changed for shape, for circle, for shape, for rectangle. Now for destructor, something surprising. For destructor, it says destructor for shape get, you see, first we need to release a rectangle, right? Delete S. So we are expecting the destructor for rectangle get invoked, then the destructor for shape get invoked. Instead, what we see is only destructor for shape get invoked. Destructor for rectangle gets skipped. But for circle, it was alright. So you see the effect of not having virtue in front of the parent class destructor. When you don't have that virtue here, when you create an object this way, kind of like you're trying to enable dynamic bonding there. When you delete that S, delete that rectangle, the subclass destructor didn't get invoked. That's why you should always make your destructor virtue when you expect you might have some subclasses. So when you expect somebody to extend you to inherit from you, you should always make your destructor virtue. That way, when they try to use dynamic bounding, the destructor for your subclasses could be guaranteed to get invoked. So after I put it back, and let's run it, and everything's fine. You see destructor for rectangle get invoked here, then for shape. Alright, thank you.